All right, so here we are taking a look at number 2 from the constructed response for the Unit 6 test. The context here says that a woman got a speeding ticket on the way home from work. If she pays within 30 days, there will be no added penalty. If she delays her payment, then a penalty will be assessed for the number of months T that she delays paying her fine. Her total fine, F, in dollars, is indicated in the table below. Okay, so this tells us, like at month, if she doesn't pay her fine, after 2 months, she's going to have to pay $450.26. After 3 months, she's going to have to pay $675.84. After 4 months, $1,012.60. 5 months, $1,518.95. Okay, so it goes up quite a bit as time goes on. So part A says which type of function, linear or exponential, best models the situation, and we want to explain our answer. Okay, now if you'll remember, if you are going to have a linear function looking at a table, linear is the common difference. Okay, that means we subtract. Okay, if we have an exponential situation, that's the common ratio, and we divide. So just by looking at these numbers, like these are about 200 apart, but then these are 400 apart and these are 500 apart. I see that the common difference is not the same throughout my function just by looking at the numbers quick. If you're someone who kind of needs that validation, you could test it out. So if you pull up your calculator and you went to that last term, 15, 18, 95, and I subtract 10, 12, 60, I get 506.35. Well, if I do it again with my next 2 points, I get 336.76. So we can see right there that they're quite a bit different. So it's not going to be a linear function. So let's test to see if it's exponential. It should be because it's an either or question. But here we can find our ratio, and this will help validate our answer as well. So 15, 18, 95 divided by 10, 12, 60, that gives us 1.5. Okay, so that would be my growth factor, how fast it's growing. So if I test it again with my next two values, so I'm going to move down that list, so 10, 12, 60 divided by 675, 84. Okay, I get 1.498, which is really close to 1.5, right? But this is real data. So if your numbers are like off by hundreds or thousands of a decimal point, that's okay, because in real data, remember how we talked about how real data might not follow the curve exactly, but it'll still look linear, or it'll still look exponential when you graph it. It'll just kind of be off just slightly from a perfect curve, because real data doesn't follow perfect functions. Okay, we use functions to help describe the data, but very rarely do we have a data set that perfectly follows an exponential curve. Okay, so let's test it again. So if I go to 675, 84, and I divide 450, 26, I'm back up to that 1.5. So we are golden. We have a common ratio. The common ratio is the same. It's 1.5 if we round for all of them. So when we're giving our answer here, we can say that it's exponential because the common ratio is the same for each I'm going to say as each input changes by 1. So we're comparing our x values by 1. So like 4, we went from 5 to 4, 4 to 3, 3 to 2. Okay, and then we could show some work here to show that you got the common ratio. So I would just, if I were you, showing my work here, I would just type out what we got. Okay, and then 1 point, and you could just round. Okay, because when we round, we'd end up with 1.5 every time. Okay, so I'm showing here that my common ratio is the same for each change of x's as I go in months by 1 unit at a time. Okay. So in part B, it says to describe the approximate monthly growth demonstrated in the table using words. Well, we just found in this last part A, we just found the growth factor. It's 1.5. Okay, so when we're describing that, that 1.5 means that as the months go up, so as we increase by a month, the amount of money that she's going to owe on her ticket is going to increase by 1.5 times. All right, so for every month that she doesn't pay her ticket, she owes 1.5 times as much as the month before. Okay, so that's describing what's happening in the situation. Okay, so you're just going to take your growth factor that you found in part A and you're going to put it into a sentence to describe the situation that you have. And then for part C, it says assuming that the growth rate was the same for the entire year, so every month in this year, the growth rate doesn't change. It says give an estimate amount for the fine for month 1. We want to show the work or explain our answer. So I'm going to show work. So I have 2 to 5, and notice as we go down in months, we're increasing in time. Okay, so this is like 450.26 times 1.5 gets us to the next answer, times 1.5 gets us to the next answer, times 1.5 gets us to the next answer. But if we want to go the other way, if I want to go backwards, we know that the inverse operation of multiplication is division. So if I want to go to month number 1, I could just take this amount and divide it by 1.5, and that's going to tell me how much I owe in month number 1. So month number 1 would equal that 450.26 divided by my growth rate of 1.5. So the amount that we would owe, if I bring up my calculator here and I do that math, so 450.26 divided by 150, we end up with $300.17. Okay, so there's the work. That is sufficient for part C.